Alright, here's a video on integration by parts. I think I'm going to actually do two of these, so I'm going to call this part 1. So, first of all, let me tell you about the formula for integration by parts and where it comes from. In a manner of speaking, integration by parts is as close as we can get to a reverse product rule. If you remember the product rule, that this is the product rule from Calc 1. The product rule is for when you're trying to do the derivative of a function times another function, and it gives you this nice formula for it. There isn't really such a integration by parts is as close as we're going to get to a reverse version of this. In a sense, it is a reverse version of this. It's just not as, it doesn't always really get you the answer. Anyway, we'll see what I'm talking about. So this is the product rule. Now, if I were to take the antiderivative of both sides, on this, I just have the antiderivative of the thing on the right. And so that, this antiderivative should be, it should equal the antiderivative of what's on the left. Of course, the antiderivative of what's on the left, because what's on the left is just the derivative of something. So if I take the antiderivative of a derivative, I just get the thing inside. So I get f of x times g of x, and I'm going to write plus c because these are indefinite integrals. So this indefinite integral is f of x times g of x plus c. Okay, now we're going to manipulate this a little bit. Of course, this integral has basically two things that are being added together, and we know that I can separately do the integral of this part and the integral of this, but just imagine another integral sign here. If I were to split this into two integrals, and maybe I'm going to leave this one on this side, so it just goes there. And I'm going to take this one and move it to the other side. So this one stays there, this one moved there, this still has an f of x and a g of x, so that's all that happened. And by the way, I didn't write plus c because now that I'm writing it this way, both sides have integrals on them. So I'm in my imagination, there's an implicit plus c when I write this integral. That's how I'm thinking of this. And if I decide to use some letters, I'm going to let u be f of x and v be g of x. That way, du would be, to find du, I just do the derivative of this and I stick a dx on it, so it would be f prime of x dx. And similarly, dv would be g prime of x dx. And then I go back to what I wrote above. I can write it this way, right? Let's follow this. So this f of x gets replaced with u, and that's there. G prime dx is the same as dv, so that goes there. F of x is u, so that goes there. G of x is v, so that goes there. G of x is v, so that goes there, and the f prime of x dx is du, so that goes there. So everything is there. This is just another way of writing it. And this is what I'm going to stick a box around. This is the formula that we call integration by parts. And when you've seen me doing substitutions, you've seen me avoid the letter u. I often use the letter w for substitutions. And finally, we get to the reason why. That's because I reserve the letters u and v for integration by parts. I don't use them for anything else. The risk is if you use u for a substitution, you might find later in the problem that you ultimately want to end up doing integration by parts. But if you're already using the letter U, then it gets awkward, because you're gonna have, you have to say, well, U means something else now, and then that can be confusing. Anyway, let's use this. So let's do the following integral, and I'm going to give you advice very shortly about what to make U and what to make dV, because we always have a choice for this. Part of this function that I'm looking at is going to be U, and part of it's going to be dV, but we always have a choice of, like, do I want U to be like e to the x, or do I want U to be the x part, or maybe I should have U being the whole thing. For now, this is our first example. Let me just tell you what a good choice is. I'm going to let U be x. Now, dV just has to be the rest, and dV should include the dx. Like, d's go with d's. So dV just has to be everything that I didn't make U. So e to the x dx. Okay. Whenever we do integration by parts, I'm going to need to find the du, and so the derivative of this is just 1. Here, I'll write the 1, even though it's silly, and then we put a dx there. I'm also going to want to know v. For that, I'm doing an antiderivative. Here, usually I don't go so far as to write this, but this is our first time. So v is the antiderivative of dv. This is going to be e to the x. And by the way, typically when I'm doing antiderivatives, if it's an indefinite integral, I put a plus c. There's no reason to put a plus c for this step of integration by parts. Technically, what I would describe this as is v could be any antiderivative. It doesn't, when we put a plus c, that's like finding every possible antiderivative. If I just leave it off, that's un-antiderivative still. It's like I'm saying c equals 0. So I don't need every possible antiderivative. It's just one possible antiderivative. That's good enough for v. Okay, so it's u times v minus the integral of v du. In other words, it's x times e to the x minus the integral of e to the x, and then du is just dx. Okay, now we have to take a step back. Here's the thing. Integration by parts has the power to make your life even worse than it was before, and we try not to let that happen. But how that can happen is integration by parts doesn't really do all the work for you. You start with integral of u dv, and then it gives you this, which has an integral in it. And we just have to hope that the new integral is easier to do than the one we started with. Otherwise, we made our lives worse. And like I said, I'm going to give you advice for how to choose your u and choose your dv, because if you make a bad choice, it will make your life worse. I gave us good advice this time because I'm a decent guy, and if I look at the new integral, this is something that's on our list of things that we have memorized. This is the easiest antiderivative in the world. Antiderivative of e to the x is e to the x. So that's definitely preferable to the one that I started with. In any case, let's finish it off. Antiderivative of e to the x is e to the x, and since I'm at the end and I just completed all my integrals, this is where I start writing a plus c. This is the antiderivative of x times e to the x. Okay. Let's do another one. Let's first, let me tell you my advice for how to choose u and dv. Now, let me preempt this by saying it is very hard and perhaps impossible for me to give you advice that will be the best possible advice in every possible situation. This is just what I would try first. But typically, this is going to lead you in the right direction. But I do want to warn you that there are all kinds of weird examples because integration is very hard and sort of finicky. But here's the advice. And what I remember is LIPTE. What these are is it's priorities for you. I go down the list. The first thing I check is L, which stands for logarithm. If I see that my function involves any logarithms, like ln x, or less commonly you might see log base 3 of x or log base 2 of x or whatever, if I see any of those things, I'm going to make that u. And that's my first priority. If I don't see any logarithms, then I go down the list. So the next thing I check for is I, which stands for inverse trig function. Inverse trig function is like arc sine x, arc tan x. Sometimes you see them written as like, it looks like sine to the -1. I don't really like that notation, but so it's those things. It's the inverse trig functions. So if I see any of those, I make that u. And if I don't, then I go farther down the list. Again, these are priorities, so I keep going until I find one of these things. The next thing I check for is a power of x, like it could be x squared. Of course, square root of x is like secretly a power of x because it's x to the 1/2, so I would count that as a power of x. It could also just be x to the 1. That counts as a power of x. And if I don't see that, then I move on to the letter t, which is like the standard trig functions, not the inverse trig functions. So this is just like regular sine, regular tangent, so on. And then finally, exponential, like e to the x, or less commonly you might see like 2 to the x or 10 to the x or something. So once again, you go down the list, you make u equal to whatever the first thing on the list you see, and of course dv just has to be the rest. Like dv is everything that you didn't include in your u. And that should, in most situations, lead you in a good direction. Okay. So with that in mind, let's do one more example real quick. So if I'm going to use integration by parts, the first choice is what to make u and what to make dv, and we just found out this advice. So I go down the list, and actually I see the very first thing. I do see a logarithm. I see ln x. So that's going to be my u. dv, I am obligated to just include everything else, so that's going to be the x squared and also the dx. The dx always goes with dv. Okay. In order to use integration by parts, I'm going to need du, and I'm also going to need v. So du is the derivative of ln x, that's 1 over x dx. V is I'm finding the antiderivative of this, and it could be any antiderivative again, so I'm not going to write plus c for my answer, so I'm just going to write 1/3 x cubed. Okay. This turns into, I've got my formula right here, it's uv minus the integral of v du. So here I go. U times v is, maybe I'll write this first. It looks a little better. So that's u times v minus the integral of v du, which is 1/3 x cubed, and then du is 1 over x dx. Okay. And once again, we're in this spot where, okay, we did integration by parts, but it doesn't jump straight to the answer. There's a new integral that we have to worry about, and we're always just hoping that the new integral is better than the old integral. Let's clean it up. I can pull the 1/3 out, and then I can cancel an x. And that cleaned up very nicely. This is an easy integral to do. So I've got this 1/3 that was already there. When I integrate x squared, that's going to introduce a new 1/3, and then x cubed. And now I've done all my integrals, so now is the time to start writing plus c. And I can simplify. I mean, I'm just going to do 1/3 times 1/3. That's all I'm going to do. And that's all there is. Okay, so maybe I'll leave this video at that, but again, I'm going to do a second video about U substitutions. Or, sorry, I meant integration by parts, of course.